An inverse relation just interchanges the input and output values of the original equation. You rewrite to get y or f of x alone. We're going to look at that in a second. When both an original equation and its inverse are functions, that'll be tomorrow. So, okay, give me, I don't know, 6 minutes and I'll be done. Okay, let's do it. Maybe more. Find an equation for the inverse of the relation. All you have to do when you find the inverse is you switching x and y and solving for y. And that gives you the inverse. So I'm going to take and I'm going to switch x and y. And then I'm going to solve for this y. And that gives me the inverse. So you add 4 to both sides. X plus 4 equals 7y. Divide by 7. And I would get this. I could write it as x, oh, you got to split up the fraction. You can write it like that. So I took and I split up this fraction. Or you might see it like this. This is like slope-intercept form right here. Either way is acceptable. This is the inverse of that. Where did I lose you? Right here.
I'm good.
Just keep going.
Okay.
Why do we have to slope the fraction?
Just writing it the proper way because it's a line, I guess. I don't know. That's how you'll see it in the book. So
But you couldn't write it like x plus y over 7.
leave this.
I mean, x plus 4. Yeah.
I'd rather you split it up. I mean, I probably wouldn't mark it wrong, but you might want to get in the habit of splitting it up. Okay. Functions f and g. So if you have two functions, are inverses of each other, provided that when you compose them, so if I took f of g of x and I solved, it would equal 0. No, not 0, I'm sorry, x. What am I thinking? And then, on the flip side, if you took g of f of x, that would also equal x. The function g is denoted by f to the negative 1, written, f to the negative 1, which is read f inverse. Okay? So if you take the inverse of something, you would write it as f to the negative 1 of x, and we're going to look at that. It's just a way of writing it. So here we go. Verify. We're going to prove now that f of x equals 7x minus 4, which is what we had up here, and f inverse x equals this are actually inverse functions. We got to prove that they really are. And so what we do is we compose them. We show that f of f inverse x equals x. So what you do is you take this function and put it in this function and see if it equals x when you simplify. So I'm going to say, all right, 7 times 1/7 x plus 4 over 7 minus 4. And I'm going to simplify that. So I took the inverse function and stuck it into the original function. So if I distribute that 7, what's 7 times 1/7? 1. So I'm just going to put x. I'm distributing this 7. What's 7 times 4? 28 divided by 7?
4.
Oh, look at that.
Are we going to have to prove that?
Yep.
Know it?
And then we do this other one.
Wait, what?
Okay?
Oh, I get
So now I'm going to compose it the other way. I'm going to take f of x and stick it into the inverse. Okay? So it's going to look like this. 1/7, 7x minus 4, plus 4/7. I got to make sure that that equals x. 1/7 times 7 is just x minus 4/7 plus 4/7.
Magic.
Nifty.
What's your rule?
Okay? Proving that they're inverses of each other. All right. Now, I'm almost done. The last thing we're going to do is just a couple more that we're going to write the inverses of. All right? Find the inverse of each function. So what's the first step that we have to do?
Switch X and Y.
Yes, remember f of x is the same as y,
Can we just write
Yeah, why
Y
can't you just write y?
because you gotta write function notation. You have to write the inverse function as f of negative 1 to the x. Switch x and y. And then solve for y. So we subtract 1 from both sides. And then we divide by 2. So I get x minus, oops, that's a minus. 1 divided by 2 equals y to the 4th. It's a minus right there, it's not a plus. Then how do I do the 4th? 4th root. 4th root. And I'm just going to write it like this. Plus or minus the 4th root. Why did I have to put plus or minus there? Because it's an even root. Now, theoretically, it's not the most simplified form, but for writing the inverse, it'll be okay. We'll just leave it like that. Because you're not really supposed to have a root in the denominator, but we'll just leave it like that. Okay? Now, let's do this one. Actually, you try this one.
No.
Find the inverse of this one. Oh, wait, I'm not done yet. I forgot.
It doesn't say
No, he doesn't.
What should we write this as instead of y? We really should write it the proper notation f of negative 1x
What?
instead of y. Can you see that? The inverse of f of x is this.
Right, Y.
It'll be very clearly written in the directions how you're supposed to write it.
What if you accidentally write Y?
Then you'll get it wrong because it was in the
The
directions.
whole thing?
So do this one, and then you'll be done. You have your little table if you need it.
Hey, guys.
Ready? There it is.
What? That's not right. It is not right.
Isn't that? That's so illegal, it's not even funny.
You did it wrong. Yeah, 'cause it's 32.
I switched x, I made this y, then I switched x and y. Right? Yeah, it should be. And then I multiplied both sides by 32. Then I took the 5th root. And then I wrote my answer like this.
That's not you wrote it.
Why did you box the other one then?
He's feeling fancy.
I love it when